Good morning, everyone. I am Auliar Rufaida from University of Technology, Mauritius. It is with great pleasure that I am presenting my research, which is an analysis of farm-based carbon footprint calculators inside for farmers. Climate change is regarded as a major environmental and developmental challenge, adversely affecting the mean potential for sustainable development. Negative impacts of climate change notably shift weather patterns, receding ice caps, crop losses, and serious ecological imbalances, among others, have been largely felt across the globe, which are mainly due to a rise in greenhouse gases. Agricultural sector is regarded as a significant contributor of GHG from livestock, production of crop, food processing, and marketing of products, accounting for around 13.5% of the overall global anthropogenic GHG emissions. Thus, climate change disturbs the availability of food, declines the access and quality of food. Therefore, policy reforms in the agricultural sector should strengthen the incentives to farmers, organize awareness-raising campaigns to help people adopt the good practices in order to achieve sustainable productivity growth and reduce carbon emissions from farming activities. It is essential to estimate carbon footprint from farming activities in order to set up policy reforms, thus determining areas emitting more carbon. Estimating carbon footprint helps in coming up with practices towards reducing emissions and also help policymakers and farmers in identifying environmental implications of mitigation and management approaches. Also, it can be observed that carbon footprint is a popular quantitative indicator and simplifies communication between scientists, policymakers, and farmers. Additionally, carbon footprint can be measured weekly, monthly, or yearly with help of carbon footprint calculator, permitting farmers to enter respective details for a more accurate calculation. However, limited works have been undertaken to analyze how carbon calculators account for carbon emission from farming activities. Therefore, the purpose of this paper is to extend previous research on carbon footprint calculators by critically analyzing how such tools account for emissions farming activities. Moving to related works, previous study presented a farm-based carbon calculator meant for European context and was based on international standards for life cycle assessment, whereby testing was done involving 54 farms and based on 7 countries. However, the research was not focused on the comparison of existing carbon calculators. Another work examined the similarities and differences among selected carbon calculators. However, these focus on diet and personal traveling. Therefore, it was noted that limited published literature is available in the area of farm-based carbon footprint calculators, thus highlighting the importance of this research. To conduct this study, initial search was performed using Google as primary engine to identify calculators and keywords like farm, carbon calculators, agriculture, farming tools were used. 16 calculators were identified out of the initial search. To narrow the result, calculators estimating carbon footprints for both crops and livestock with no country specificity restrictions were chosen. In this process, 3 calculators were found relevant, notably Farm Carbon Cutting Toolkit, Coal Farm Tool, and Farming Enterprise Greenhouse Gas Emission Calculators. Frameworks from previous study were adopted to compare selected calculators due to the relevance in comparing carbon footprint calculators. Based on the frameworks mentioned in the previous slide, different criteria are involved for comparing calculators, and these are: scope relates to the various categories and inputs required while calculating carbon emissions. Calculating methods involves determining the approach used by the calculators for calculating carbon emissions. Consistency of results relates to the uniformity of results of calculation produced across calculators. To analyze scope calculation method and consistency of calculators, 5 cases were derived and are as follows. So we have 5 farmers, farmer A, B, C, D, and E, each having their respective crop grown and livestock, and are each from different regions in Mauritius. Data from each profile is to be input in the free-form-based calculators to compute respective carbon footprint of farmers, and information presented in the carbon calculators were studied to further comprehend scope and calculation method. Now let's discuss about the results of this study. The table on the screen combines the various calculators along with the categories and inputs involved in the calculation process of carbon footprint. In addition to varied categorization in the previous slides, differing granularities in terms of input parameters for each category were noticed. This also implies some calculators required more input than others. Moreover, it was noted that not all calculators accounted for important criteria, notably soils as well as their parameters. Therefore, lack of consideration of parameters lead to inaccuracy in the estimates of carbon footprints. It was also noticed that some calculators have taken into account majority of parameters required, thus denoting a higher granularity of inputs and more accurate estimates. As such, cold form tool and form cutting toolkit are considered as calculators providing higher granularity. However, this study demonstrated a lack of a standardized approach for categorizing emission parameters and inputs. Let's now discuss about the results obtained for calculation method. Cold Form Toolkit makes use of a well-defined method for estimating footprint for different emission categories considered by the calculator. For instance, for soil, the calculator goes beyond the IPCC Tier 1 and Tier 2 techniques involving direct and indirect nitrate oxide emissions, embedded emissions from mineral fertilizers, and changes in soil carbon stock. Farm Carbon Cutting Footprint Toolkit is a calculator for farmers in UK and makes use of Tier 1, 2, and 3 emission approaches. However, due to lack of documentation on this particular tool, the emission approach used cannot be clearly certified and details of calculations are unknown. As such, lack of transparency makes it unclear about the approach used, emission factors and formula, among other aspects involved in the calculation process. Lately, farming Enterprise Greenhouse Gas Emissions Calculator is a calculator with lack of documentation, thus the carbon footprint approach remains undetermined. As such, among the three calculators analyzed, it can be noticed that Cold Form tool is the calculator with a detailed explanation of the approaches used by the calculator. On the other hand, lack of transparency prevails among form-based carbon footprint calculators, where the calculation method used by Farm Carbon Cutting Toolkit and Farming Enterprise Greenhouse Gas Emission Calculator cannot be determined due to lack of information published. Let's move on with consistency of results. As demonstrated on the right, the annual carbon footprint for the 5 farmers detailed earlier were calculated via the 3 selected calculators, and respective values are provided along with the mean, variance, and standard deviation for each farmer. Results show that every calculator provided a different annual carbon footprint for the same farmer. Among the studied calculators, it was found that Farm Carbon Cutting Toolkit and Cold Form tool provided relatively closer value as compared to Farming Enterprise Greenhouse Gas Emissions Calculator. The varied carbon emissions could be due to different reasons, notably different calculation methods, number of inputs, and emission factors, among others. Among the 5 profiles, variance was lowest at Farmer A and highest for Farmer B. It was noticed that as the number of farming activities increases, more inputs need to be made in the calculators and consequently variance increases. This also potentially justifies the low variance for Farmer A, which has a relatively low number of inputs as compared to Farmer B and E. Overall, carbon footprint results were significantly inconsistent across studied calculators. As general discussions, it was observed that significant enhancements were needed to ensure reliability of results from such tools. Categories and inputs can be better standardized and regulated. Moreover, conversion tools can be added. Form-based carbon calculators are encouraged to provide information on the calculation methods, and it is essential to implement measures towards enhancing consistency and reliability of results provided by such tools. However, none of the calculators studied were mobile-based applications and required the use of a browser, thus making it difficult to access. The selected calculators permitted only yearly carbon estimates from farming activities. Better management of GHG emissions and practices to reduce footprints are promoted with a monthly basis calculation. This paper analyzed the key aspects of farming-based carbon calculators, notably their scope, calculation method employed, and consistency of results provided. In order to achieve the purpose of this paper, free-form-based carbon footprint calculators were utilized and critically analyzed. To study the scope of the selected calculators, farming categories and input parameters were investigated. It was found that selected calculators categorized farming activities via inconsistent ways, and the granularity of the input varied significantly. Likewise, to investigate on the method of calculation, information provided in the websites and within published documents were referred to. As a result, it was noted that 2 out of the 3 calculators studied published limited information. 5 profiles of farmers were created and their carbon footprints were calculated to analyze consistency of results. Results showed some inconsistencies in terms of computed carbon emissions, which could be due to the underlying calculation method used. Overall, given the importance of carbon footprint calculators towards reducing and communicating carbon emissions from farming activities, further efforts are required from the research community and developers of such tools to further address the limitations identified in this study in terms of scope, transparency of calculation method used, and consistency of results provided by such tools. As future works, this study could be extended to further include regional farming carbon calculators, while enlarging the aspects of comparison to include communication methods and usability issues. Here is a list of references used to carry out this study. Thank you for your attention.